The north coast of California has rainforests, temperate rainforests, where it can rain more than 100 inches a year. And this is the realm of the coast redwood tree. Its species name is Sequoia sempervirens. Sequoia sempervirens is the tallest living organism on Earth. The range of the species goes up to as much as 380 feet tall. That's 38 stories tall. These are trees that would stand out in Midtown Manhattan. Nobody knows how old the oldest living coast redwoods are, because nobody has ever drilled into any of them to count their annual growth rings. And in any case, the centers of the oldest individuals appear to be hollow. But it's believed that the oldest living redwoods are perhaps 2,500 years old, roughly the age of the Parthenon. Although it's also suspected that there may be individual trees that are older than that. You can see the range of the coast redwoods. It's here in red. The largest individuals of the species, the dreadnoughts of their kind, live just on the north coast of California, where the rain is really intense. In recent historic times, about 96% of the coast redwood forest was cut down, especially in a burst of intense liquidation logging, clear cutting that took place in the 1970s through the early 1990s. Even so, about 4% of the primeval redwood rainforest remains intact, wild, and now protected, entirely protected in a chain of small parks strung out like pearls along the north coast of California, including Redwood National Park. But curiously, redwood rainforest, the fragments that we have left to this day, remain underexplored. Redwood rainforest is incredibly difficult to move through. And even today, individual trees are being discovered that had never been seen before, including, in the summer of 2006, Hyperion, the world's tallest tree. I'm going to do a little Gedanken experiment. I'm going to ask you to imagine what a redwood really is as a living organism. And Chris, if I could have you up here. I have a tape measure. It's a kind loaner from Ted. And Chris, if you could take the end of that tape measure. We're going to show you what the diameter at breast height of a big redwood is. Unfortunately, this tape isn't long enough. It's only a 25-foot tape. Chris, could you extend your arm out that way? There we go, okay. And maybe about here, about 30 feet is the diameter of a big redwood. Now, let your imagination go upward into space. Think about this tree rising upward into redwood space, 325 feet. 32 stories, an individual living organism articulating its forms upward into space over long periods of time. The redwood species seems to exist in another kind of time, not human time, but what we might call redwood time. Redwood time moves at a more stately pace than human time. To us, when we look at a redwood tree, it seems to be motionless and still. And yet redwoods are constantly in motion, moving upward into space, articulating themselves and filling redwood space over redwood time, over thousands of years. Plant this small seed, wait 2,000 years, and you get this, the lost monarch. It dwells in the Grove of Titans on the north coast and was discovered in 1998. And yet when you look at the base of a redwood tree, you're not seeing the organism. You're like a mouse looking at the foot of an elephant, and most of the organism is overhead, unseen. I became very interested, and I wrote about a couple. Steve Sillett and Marie Antoine are the principal explorers of the redwood forest canopy. They're world-class athletes, and they also are world-class forest ecology scientists. Steve Sillett, when he was a 19-year-old college student at Reed College, had heard that the redwood forest canopy is considered to be a so-called redwood desert. That is to say, at that time it was believed that there was nothing up there except the branches of redwood trees. And with a friend of his, he took it upon himself to free climb a redwood without ropes or any equipment to see what was up there. He climbed up a small tree next to this giant redwood, and then he leaped through space and grabbed a branch with his hands and ended up hanging like catching a bar of a trapeze. And then from there, he climbed directly up the bark until he got to the top of the tree. His friend, a guy named Marwood Harris, was following behind. Neither one of them had noticed that there was a yellow jacket wasp nest the size of a bowling ball hanging from the branch that Steve had jumped into. And when Marwood made the jump, he was covered with wasps, stinging him in the face and eyes. He nearly let go. He would have fallen to his death, being 75 feet above the ground. But they made it to the top. And what they found was not a redwood desert, but a lost world, a kind of three-dimensional labyrinth in the air filled with unknown life. Now, I had been working on other topics, the emergence of infectious diseases, which come out of the natural ecosystems of the Earth, make a trans-species jump and get into humans. After 3 books on this, it got to be a bit much in a way. My wife and I adore our children, and I began climbing trees with my kids as just something to do with them, using the so-called arborist climbing technique with ropes. You use ropes to get yourself up into the crown of a tree. Children are incredibly adept at climbing trees. That's my son Oliver. They don't seem to suffer from the same fear of heights that humans do. If ontogeny recapitulates phylogeny, then children are somewhat closer to our roots as primates in the arboreal forest. Humans appear to be the only primates that I know of that are afraid of heights. All other primates, when they're scared, they run up a tree where they feel safe. We camped overnight in the trees, in tree boats. My daughter Laura, then 15, looking out of a tree boat. She's, by the way, tied in with a rope, so she can't fall. Looking out of a tree boat in the morning and hearing birdsong coming in 3 dimensions around us. We had been visited in the night by flying squirrels who don't seem to recognize humans for what they are because they've never seen them in the canopy before. And we practiced advanced techniques like skywalking, where you can move from tree to tree through space, rather like Spider-Man. It became a writing project. When Steve Sillick gets up into a big redwood, he fires an arrow which trails a fishing line, which gets over a branch in the tree, and then you ascend up a rope which has been dragged into the tree by the line. You ascend 30 stories. There are 2 people climbing this tree, Gaia, which is thought to be one of the oldest redwoods. There they are. They are only 1/7 of the way up that tree. You do feel a sense of exposure. There's a small person right down there on the ground. You feel like you're climbing a wall of wood. But then you enter the redwood canopy, and it's like coming through a layer of clouds. And all of a sudden, you lose sight of the ground, and you also lose sight of the sky. And you're in a 3-dimensional labyrinth in the air, filled with hanging gardens of ferns growing out of soil, which is populated with all kinds of small organisms. There are epiphytes, plants that grow on trees. These are huckleberry bushes, many species of mosses, and then all sorts of lichens just plastering the tree. When you get near the top of the tree, you feel like you can't fall. In fact, it's difficult to move. You're worming your way through branches, which are crowded with living things that don't occur near the ground. It's like scuba diving into a coral reef, except you're going upward instead of downward. And then the trees tend to flare out into platform-like areas at the top. Marie is sitting on one of them. These limbs could be 500 to 600 years old. Redwoods grow very slowly in their tops. They also have a feature, thickets of huckleberry bushes that grow out of the tops of redwood trees that are technically known as huckleberry afros. And you can sit there and snack on the berries while you're resting. Redwoods have an enormous surface area that extends upward into space because they have a propensity to do something called reiteration. A redwood is a fractal. And as they put out limbs, the limbs burst into small trees, copies of the redwood. Now here we see a reiteration in Kronos, one of the older redwoods. This reiteration is a huge flying buttress that comes out. The tree itself, this buttress is less than halfway up the tree. And then it bursts into a forest of redwoods. This particular extra trunk is 1 meter across at the base and extends upward for 150 feet. It's as big as any of the biggest trees east of the Mississippi River, and yet it's only a minor feature on Kronos. This three-dimensional map of the crown structure of a redwood named Iluvatar, made by Steve Sillett, Marie Antoine, and their colleagues, gives you an idea. What you're seeing here is a hierarchical schematic development of the trunks of this tree as it has elaborated itself over time into 6 layers, a fractal of trunks springing from trunks, springing from trunks. I asked Steve to put a human being in this to give a sense of scale. There's the person right there. The person is waving to us. I've wanted to ask Craig Venter if it would be possible to insert a synthetic chromosome into a human so that we could reiterate ourselves if we wanted to. And if we were able to reiterate, then the fingers of our hand would be people who looked like us, and they would have people on their hands, and so on. And if we had redwood-like biology, we would have 6 layers of people on our hands, as it were. And it would be a lovely thing to be able to wave to someone and have all our reiterations wave at the same time. To reiterate the point. Let's go closer into Iluvatar. We're looking at that yellow box. And this hallucinatory drawing shows you everything you see in this drawing is Iluvatar. These are millennial structures, portions of the tree that are believed to be more than 1,000 years old. There are 4 humans in this shot. 1, 2, 3, 4. And there's also something that I want to show you. This is a flying buttress. Redwoods grow back into themselves as they expand into space. And this flying buttress is a limb shot out of that small trunk, going back into the main trunk and fusing with it. Flying buttresses, just as in a cathedral, help strengthen the crown of the tree and help the tree exist longer through time. The scientists are doing all kinds of experiments in these trees. They've wired them like patients in an ICU. They're finding out that redwoods can move moisture out of the air and down into their trunks, possibly all the way into their root systems. They also have the ability to put roots anywhere in the tree itself. If a portion of a redwood is rotting, the redwood will send roots into its own form and draw nutrients out of itself as it falls apart. If we had redwood-like biology, if we got a touch of gangrene in our arm, then we could just, extract the nutrients and the moisture out of it until it fell off. Canopy soil can occur up to 1 meter deep, hundreds of feet above the ground. And there are organisms in the soil that have as yet no names. This is an unnamed species of copepod. A copepod is a crustacean. These copepods are a major constituent of the oceans, and they are a major part of the diet of grazing baleen whales. What they're doing in the redwood forest canopy soil, hundreds of feet above the ocean, or how they got there, is completely unknown. There are some interesting theories that if I had time I would tell you about. But as you go and you look closer at a tree, what you see is increasing complexity. We're looking at the very top of Gaia, which is thought to be the oldest redwood. Gaia may be 3,000 to 5,000 years old. No one really knows. But its top has broken off and it's been rotting back now. This little Japanese garden-like creation probably took 700 years to form in its complexity that we see right now. As you look at a tree, it takes a magnifying glass to see a giant tree. I have to show you something unfortunately very sad at the conclusion of this talk. The eastern hemlock tree has often been described as the redwood of the East. And we're moving a full circle now. In the 1950s, a small organism appeared in Richmond, Virginia, called the hemlock woolly adelgid. It made a trans-species jump out of some other organism in Asia, where it was living on hemlock trees in Asia. When it moved into its new host, the eastern hemlock tree, it escaped its predators, and the new tree had no resistance to it. The eastern hemlock forest has been considered in some ways the last fragments of primeval rainforest east of the Mississippi River. I hadn't even known that there are rainforests in the east, but in Great Smoky Mountains National Park, it can rain up to 100 inches of rain a year. And in the last 2 to 3 summers, these invasive organisms, this kind of Ebola of the trees, as it were, has swept through the primeval hemlock forest of the East and has absolutely wiped it out. I climbed there this past summer. This is Great Smoky Mountains National Park, and the hemlocks are dead as far as the eye can see. And what we're seeing is not just the potential death of the eastern hemlock species, that is to say, its extinction from nature due to this invading parasite, but we're also seeing the death of an incredibly complex ecosystem for which these trees are merely the substrate for the aerial labyrinth of the sky that exists in their crowns. It's absolutely heartbreaking to see. One of the things that is just, I almost can't conceive it, is the idea that the national news media hasn't picked this up at all. And this is the devastation of one of the most important ecosystems in North America. What can the redwoods tell us about ourselves? Well, I think they can tell us something about human time, the flickering, transitory quality of human time, and the brevity of human life, the necessity to love. But we are different from trees, and they can also teach us something about ourselves in the differences that we have. We are human, and we have the capacity to love, we have the capacity to wonder, we have a sort of boundless curiosity, a restless inquisitiveness that so suits us as primates, I think. And at least for me personally, the trees have taught me an entirely new way of loving my children. Exploring with them the forest canopy has been one of the most lovely things of my existence on Earth. And I think one of the happiest things is the sense that, that with my children, I've been able to introduce them into the very small circle of humans who are lucky enough, or possibly stupid enough, to still climb trees. Thank you very much.
I think at a previous TED, I think it was Nathan Mervold who told me that it was thought that because these trees are like 2,000 years and older, that in many of them there are ecosystems where there are species that are not found anywhere on the Earth except on that one tree.
Yes.
Is that correct?
That is correct. I mentioned Hyperion, the world's tallest tree. And I was a member of a climbing team that made the first climb of it in 2006. And while we were climbing Hyperion, Marie Antoine spotted an unknown species of golden brown ant about halfway up the trunk. Ants are not known to occur in redwood trees, curiously enough. And we wondered whether this ant, the species of ant, was only endemic to that one tree or possibly to that grove. And in subsequent climbs, they could never find that ant again. And so no specimens have ever been collected. We don't know what it is. We just know it's there.
Huh. So you have to wonder when, if some other species than us was recording the stories that mattered on Earth, our stories are about Iraq and war and politics and celebrity gossip. You've just told us a different story of this tragic arms race that's happening, and maybe whole ecosystems gone forever. It's an amazing sense of wonder you've given me, and a sense of just how fragile this whole thing is.
It is fragile, and I think about emerging human diseases, parasites that move into the human species, but that's just a very small facet of the much greater problem of invasions of species worldwide, all through the ecosystems. And the Earth itself...
Partly caused by us, inadvertently.
Caused by humans, caused by the movement of humans. You could think of the Earth's biosphere as a palace, and the continents are rooms in the palace, and the islands are small rooms. But lately, the doors of the palace have been flung open and the walls are coming down.
Richard Preston, thank you very much. I think. Thank you.
It's a sports car, yet a sedan. Powerful, yet fuel efficient. Modern, yet timeless. Introducing the new BMW 3 Series, our most advanced 3.